Assalamu alaikum wa rahmatullahi wa barakatuh. يعطيك العافية. Here in this question about vectors and adding vectors to draw a vector diagram to find the resultant force. Here in this question, state the factors which completely describe a vector quantity. Any vector quantity has a direction. Of course, it has a magnitude, but completely described, it must has a direction, okay? An airplane flying towards the east in still air, okay, at 92 meters per second. A wind starts blowing at a speed of 24 towards the north. Draw a vector diagram to find the resultant force. Now, to do that, to find this, okay, drawing, we know that they ask about the resultant speed and they ask about the direction, okay, to the eastern direction. Now, to do this, I want to find what? I want to draw two arrows, each arrow with a scale to these velocities with their directions, one to the east and one to the north. So that means if in this empty space, I'll draw one to the east, and the end of it, I'll draw one to the north, but into a scale. So how can I do this? I need a meter rule and a protractor to start drawing like this. So if I go to this program and I use a ruler and a protractor that from here, okay? So we have ruler. I want to put a scale. That's my scale. It will be each 1 centimeter is 10 meters per second square. So each 1 centimeter is equal to 10 meters per second. That means this 92, okay, meters per second, it will be 9.2 centimeter. And the other force, which is 24 meters per second, it will be 2.4 to the north, okay? So first of all, let's draw the first one with a blue line, starting from 0, okay? And to how much? To 9.2. So this is 9.2. Let me repeat this again. To 9.2 until here, exactly. Then what? I'll bring my compass, protractor, to make sure that I'm drawing a 90 degrees angle to this line. Okay, here, 90 degrees. This is my other force. It will be starting from here. Okay, how long it will be? I will now use the ruler again to put it like this and see how many centimeters it will be. It will be 2.4 centimeter. So this is 1, 2, 2.4, like this until here. Okay. Then my answer, it will be from the initial point here to the final point where I reach until what? Until here. This is my resultant. I'll draw it like this. Okay. I need to measure how long it is. And as you can see, it's 9.5 centimeter. So my answer, okay, the resultant of my answer, the resultant velocity, equal 9.5 centimeter, which means 95 meters per second. And let's measure the angle that they ask about it to the eastern direction, this angle. And as you can see, that this angle, it's 15 degrees. So the angle theta to the eastern direction, it's 15 degrees. This is for this question, which is easy. So the answer here, the resultant, it will be 95 meters per second, and the direction, it's 15 degrees. We have several questions to answer here. Let's go on to the question that one of the students asked about it. It's in this question. This is May, June 2006. Okay. And this question, what they said, a student set up the apparatus to show in the figure in order to find the resultant force of two tensions T1 and T2 at a point P as shown. Okay, T1, T2, and T3 with a load here, they make it them equilibrium with an angle shown here. In the space below, draw a scale diagram for the tensions T1 to T2. Use them to find the resultant force of T forces. So what are the scale that I'll use? Okay, we have 8 centimeter, 8 Newton and 6 Newton with an angle of 44 and 69. So the scale, it will be very easy. 1 centimeter equal 1 Newton. And I would redraw. I'll use the information here to draw. Okay. So let's try to draw it. Okay. Let's go to the program here again. Okay. What do we have? Okay, forget this writing here. Okay, now we will use the protractor. We'll put it to draw the vertical line and the horizontal line. Okay, this is the horizontal line. I don't need it so far. This is the vertical line. I don't need it. Okay, so far. What do I need? I need an angle of 44 degrees. So this is 44 degrees from the vertical. Okay, let's put it like this. So it's supposed to be move this one like this until we get 44 degrees. Okay, leave this mark. Okay, and I will move this one to 90 degrees and measure the angle to 69, 68. Hey, this is 69, and I'll mark. I'll mark this line like this. Then move away the protractor. Use the ruler again. Okay, how many centimeters I'll put it? I'll put it as I told you, 8 centimeters. They give us the scale of 8 centimeters. Okay, 80 Newton, it's 8 centimeters. We are going to draw like this. So this is 8 centimeters, and I'll use it to draw the other one here of 6. Okay, this is 6 centimeters. Then I will move the protractor, or I'll use the compass and measure this angle. Now we know that in parallelogram, if this angle is 69 and this angle is 44, so the opposite of this angle, that means I mean by this angle, it's supposed to be a corresponding angle like this. These two sides are parallel, so this angle with this angle, they have to be how much? 180 degrees. So by finding 180 minus 69 and 44 degrees, that means this angle, it will be how much? 67. You can use the protractor to measure it and draw how many? 6 centimeters, which is equal to this one. And I will redraw this, the other force of 80 Newton. So here we have 80 Newton. Don't forget to label 80 Newton. And here we have 6 Newton. Okay, so this is the 6 Newton again. And I'll use the protractor to find the same angle. Okay, and I'll draw an 8 centimeter, and you will see that they will intersect at the same point. Okay, this is my 8 centimeter. Now our resultant is supposed starting from the initial point where I start drawing to the last point where I start drawing. Okay, and it will be like this. This is our resultant. And the resultant, as you can see, it has a scale of by using the ruler of 8 centimeter approximately. So the resultant force is equal to 8.0 watt centimeter, and the direction of it is upwards. This is the direction, and this is 80 Newton. Okay, don't forget to try to draw it as big as possible. Here in my ruler is a small scale, but if you draw it on the answer, it will be bigger than the strong. It will be more accurate. And so let's continue answering the question here. The value of the resultant is 8.0 Newton, and the direction of it is upwards. And that's it. يعطيكم العافية. السلام عليكم.